Hey guys, we're starting a new chapter this week on force and Newton's laws of motion. And just kind of give you an intro, I want to tell you what forces are. A force is going to be a push or a pull on an object. To get an object to move, to get it to start in motion, or even to stop an object, we must apply a force to it. Right now, the only force acting on this object is gravity downward on the remote control. And also there's a static force that exists between the remote control and the whiteboard that it's resting upon. To get the object to move, I have to apply a force greater than that of the weight of the remote control. And when I do that, if I apply a force in a certain direction to overcome gravity and the weight of the remote control, it'll move. So forces are shown with both magnitude and direction. So the larger the arrow, the greater the strength of the force, and the arrowhead will show the direction in which that force is working. So I moved the remote control with a force of 5 newtons to the left. That's what the capital N stands for, is newtons. Now, in observing forces, forces can be either balanced or unbalanced. And our balanced forces are going to be forces that exist between objects or with objects that are not moving. Whenever the object's not moving, we say that it has a net force of 0. So for example, right now, the remote control is resting on top of the whiteboard. The forces between gravity and the whiteboard working upward on the remote control are balanced. So the net force between those two forces is going to equal 0. Now, when you have an unbalanced force, you're getting the object to move. So if you're playing golf and the ball is resting on the tee, to get that force to become unbalanced on the golf ball, with the driver or the golf club, you have to apply a force to get the object to move. So it's going to result in the object moving. When the object begins to move, it's going to have a net force that's greater than 0. So understand that when you apply a force to an object, it won't always move. And when it doesn't move, the forces are balanced, and the net force will equal 0. But once you get that object to move, even just a little bit, the net force then will be greater than that of 0, and the object will begin to move. Lastly, back to the QOD of the day, question of the day, gravitational force. The two measurements needed to determine the gravitational force created by two objects is going to be mass of both objects and the distance they are apart. The greater the mass, the greater the gravity. The closer the distance, the greater the gravity. So looking at the two examples we have here, example 1, and example 2, we explore both mass and distance to determine how it affects gravity. Example 1, the objects are further apart, and one of the objects definitely has a smaller mass. So that's going to create a smaller force of attraction between this blue object and a larger blue object. This object that has the greater mass creates a slightly larger force of gravity than a smaller object. But with example 2, the objects are both larger in mass and closer together. So the magnitude of the force of gravity created will be larger. Because the mass is greater and the distance is shorter. So greater the mass, the greater the gravity. The shorter the distance between, say, two objects or two planets, the greater the gravity as well.